Hi, welcome to this project on image classification using deep learning. In this particular video, I would like to give you a brief overview of the overall project or what we'll be covering, what are the tools and techniques that we will understand in depth. Also at the same time cover a brief set of alternatives that can be used to improve the performance of the classification techniques. To start with, I would like to give you a brief overview of what the problem statement is. So in this particular project, we are focused on classifying a set of images into two classes. Those two classes are plain t-shirts and another class is typography t-shirts. As you can see, there are two classes, so this becomes a binary classification problem. The same classification concepts that we learn here can be applied to any other binary classification problem that can apply to problems in medical domain, fraud domain, or even in email marketing domain. At the same time, the same methods that we discuss here with some minor modifications, the code and the process can be expanded to multi-category or even multi-label problems. Multi-category problems are those where the number of classes an image can belong to is one, but the number of classes are more than two. So it's similar to binary classification, but rather than having two classes, we have more than two classes. And multi-label problems are those where a single image can belong to multiple different categories at the same time. So although we won't be covering these techniques here, the same methodology and the same similar kind of code can be used with those problems. In this particular project, we will be leveraging such techniques as deep learning, which is a subfield of machine learning. Within deep learning, we'll be focusing on a particular set of techniques related to convolutional neural networks and also a similar concept called transfer learning. Along with that, we will explore some regularization topics like dropout regularization, batch normalization, and particularly for convolutional neural networks, we'll be focusing on image augmentation. These techniques are useful for making the models more generalizable and perform equally well in the real world environment. To achieve all of this, we'll be leveraging certain libraries in Python, the most crucial of which is the TensorFlow library, which is tailor-made for training deep learning models and also using them in real-world environment. You can build TensorFlow-based applications to deploy it on the edge as well. The overall project will be executed in Google Colab, which is a runtime environment provided by Google for free. The advantage with Google Colab is that they provide GPUs free of cost, although they have limits on how much of GPU memory you can use and how much of the processing can be done in any single project at any single point of time. At a high level, we will follow the following structure in the code as well as in the coming lectures. So the first step being importing libraries and a brief walkthrough of what, why, and what each one of those libraries are imported and what they are going to be used for. The second step is going to be importing and examining the data. So here we are dealing with unstructured data, which is basically images which are sourced from different domains. So we'll be focusing on like reading that data into Python and examining them, like what labels belong to what kind of images and whether there are any incorrectly labeled images and how do we deal with such situations. The next step is training the model. So here we'll be exploring different deep learning architectures, different parameters and different hyper parameters that go into improving the performance, improving the interpretability, and also at the same time making the models more generalizable in the real world. The next step is evaluating the model, provided that we have a model that is trained. We want to evaluate on a unseen data set using using certain metrics and make sure that the training metrics and the evaluation metrics are not too far off, so that we have confidence in the model that it will generalize well in the real world. The next step is examining the metrics. The Like every model should be built with a target of improving certain metrics. So here we'll be examining those metrics with the help of certain plots and also certain metrics like precision, recall, area under curve, and also visually we'll be identifying certain incorrectly labeled images which are throwing off the model from its trained performance.